Good afternoon.
Good afternoon.
All right, so what's going on? We got everybody here. That's awesome. Good to see you all here. So, okay, so tomorrow, let's talk about tomorrow. So tomorrow we've got quizzes for 8-1 and 8-2. All right, and so we're going to do, let's see, Mogion at 10 a.m., correct?
Yeah, that works.
All right, and St. John's right before class?
Yep.
And Winslow
Can we do them at 9?
at 9 to 10. Because you want to be first? You want to beat Mogion?
Yeah, that's why.
All right. Okay, but you can't be like texting them the answers and stuff like that. That's not cool. All right.
Mr. Strong, actually, I want mine at 5 a.m. now.
Me too.
You guys are awesome. All right. Okay, so let's see. Okay, so 8-1 and 8-2s tomorrow. And then today we've got just the last example on 8-3, and then we're going to start in on 8-4, which is a very short lesson. So I'm hoping we can actually finish 8-3 and 8-4 today, but we'll just see. I'm not worried about it if we don't. All right, so any questions, comments, concerns before we get started? All right, don't leave, Chloe. I saw that. Okay.
I was just throwing my trash away.
Oh, okay. That's good. That's good. All right, well, let's go ahead and get started there. So this last example, we have, so sine 3x, cosine 5x. So when the arguments are different here, then that's when you know to look for one of those formulas that you wrote down at the end of class, okay? So I'll kind of take you through the process. So when you have sine and cosine, when they're different, then that's the second one, and so you're going to use the second formula. So sine mx cosine nx is 1/2 the sine of m minus nx plus the sine of m plus nx. So you're going to use the second one here, okay? So then applying that formula, you get 1/2, which the half you can always pull in front. So then it would be the sine of 3x minus 5x plus the sine of 3x plus 5x, okay? So then you say, well, that's 1/2 the sine of negative 2x plus 1/2 the sine of 8x. All right, now, before we do this, let's talk about this negative. When you have the sign and if you have a negative inside the sign, can you disregard the negative or do you bring it in front?
Bring it in front.
You bring it in front. It's with the cosine. When the cosine argument is negative, you can disregard it, okay? But this one, you can bring it in front. So you'll have then negative 1/2 the sine of 2x dx plus 1/2 the integral of the sine of 8x dx. All right, so now the integral of sine 2x we can do. So that's the cosine, the negative cosine 2x. And then remember, when you have a number inside the argument, you divide by that. When you're taking the derivative, you use the chain rule, multiply by the 2. But when you're doing the antiderivative, you divide by the 2. The negative with the cosine will wipe out that negative there. Okay? Here we have the integral of sine 8x is negative cosine 8x divided by 8. So this negative will come in front. Now these 8s you can't cancel because this 8's inside an argument, this one is not. But what you can do is you can combine the multiply the 2 by the 8 and the 2 by the 2, and so your final answer would be 1/4 cosine 2x minus 1/16 cosine 8x plus c. All right? Any questions on the example? All right, well, let's go ahead and try practice 8. All right, so Hannah, when you've got it.
So I got sine of negative 2x over 4 minus sine of 6x over 6 plus c.
Sine of, okay, so the sine of negative 2x, you want to get rid of the negative. And so it's actually, well, okay, so when you do have the cosine of negative 2x, the cosine of negative 2x up here, you can disregard the negative. Okay, so let me go back, and this visual kind of helped me. So to help you kind of keep this straight. See, when you have a positive angle, so you imagine like an xy value. And so the x is the cosine, the y is the sine. Okay? Now, when you have that negative angle, the x doesn't change, but the y does. And so the sine of negative y is the negative of sine. The sine of negative theta is the negative of sine theta. But the cosine of negative theta is the same as the cosine of positive theta, because the x value doesn't change. Okay? So relating that, going back to the problem, when we have the cosine of negative 2x, just throw away the negative. And then the integral of cosine 2x will be sine 2x divided by 2. And then I think everything else you got right. Just that's one sine. Okay. Any questions on that? Okay, so that's it for 8.3. Okay. All right, so now we're going to go on to 8.4, which, like I said, you might notice that there's only the one side of this. Okay. So this is actually, to me, one of the reasons why I love doing the guided notes for you. This is one example where the guided notes really help me. It helped me. I teach this lesson so much better than I did 10 years ago. And at the end of the period, you're probably thinking, boy, he must have really taught it poorly 10 years ago. No, but anyway, so here's the idea, is that we're gonna use trigonometric substitutions when we have these three patterns, okay? When we have radical a squared minus x squared, radical a squared plus x squared, or radical x squared minus a squared, specifically in the denominator. But you could actually use them. I've seen some where they're not in the denominator, but 99% of the time, one of those will be in the denominator. And a in this pattern is a constant, x is a function. Now, all of these are related to the Pythagorean theorem. That's how we get these. And so we're going to make triangles that are going to help us to do that. Okay? All right. So the first one, well, these are the three triangles that we're going to use. Now, don't write we're going to go over each one separately, but I just want you to see the big picture here. Okay? So when we have radical a squared plus x squared, we're going to put that on as the hypotenuse. And then we're going to make this substitution for x. Because x will be tangent of theta, opposite over adjacent, and then you solve for x, and you get a tangent theta. Okay, when we have radical a squared minus x squared, we're going to use this triangle, and the radical is going to be one side, and we're going to use this substitution, x equals a sine theta. When we have radical x squared minus a squared, it's going to be this leg of the triangle, and we're going to use this triangle and this substitution. Okay, so as we go through, we're going to identify the radical and then figure out the triangle and the substitution that we need. Okay? All right. So, the idea, just spend a little more time on one of these triangles. So, like if this is our radical, okay, so we get the theta is tangent. The tangent of theta is x over a. So if we solve that for a, we get a is, x equals a tangent theta. And we use this triangle right here. Okay, let's do, wait, where's the first? Okay, sorry. Where did, okay, here we go. Oh, I didn't realize I had to scroll down. Sorry. Okay, so part one, the substitution x equals a tangent theta. So here's how it works. So when we have this square root of a squared plus x squared, we're going to use that substitution, x equals a tangent theta. So then when we have a squared plus x squared, and we plug in a tangent theta in for x, we'll end up with a squared tangent squared. So then we can factor out an a squared, and we have 1 plus tangent squared, and then 1 plus tangent squared is secant squared. And so when we do the substitution a tangent theta for x, but we almost always end up under the radical a squared secant squared. And so then when that will come out of the radical, because each of those are perfect squares, and so we'll just get a secant theta, usually, in our radical. So next to the blanks here, you put this in the blank. What I would like you to do is also draw this triangle here next to that blank here for part one. And you have that in your notes. Okay, so let me show you how this is going to work. All right, so let's say I had this. So when you see this, that this is like 2 squared plus x squared underneath the radical. Okay, then you're going to want to draw the triangle so that this radical is the hypotenuse. And then x is one side and 2 is over here. So 2 squared plus x squared is the square root of 4 plus x squared. Okay, so you would draw the triangle. All right, next, you're going to make the substitution x equals a tangent theta. So in this case, a squared is 4, so a is 2. So x is 2 tangent theta. All right, so then you, okay, and then this is very important, is that once you determine what x is in any of these, you write down what dx is, okay? So the derivative of 2 tangent theta is 2 secant squared theta d theta. All right, now, you're going to substitute in 4 plus x squared. And so you get 4 plus 2 tangent theta quantity squared. So when you square that out, you'll get 4 tangent squared theta. So now when you factor out a 4, you get 1 plus tangent squared theta, which is secant squared theta. And so now this is going to go under the radical. So usually I kind of do this to the side like this because I hated rewriting the integral every time. And so then this radical 4 secant squared theta is just going to end up, well, okay, let's go back. So the original integral was dx over radical 4 plus x squared. And so dx was 2 secant theta d theta. And then the 4 plus x squared ended up simplifying to 4 secant squared theta. But now each of those is a perfect square, so that's going to become 2 secant theta. Well, now, if you look, the 2's are going to cancel, and the secants cancel, and so all you have to integrate is secant theta d theta. Now, so what we've done is we've taken an integral that we couldn't do to one that we can do. And we actually know the integral of secant is the natural log of secant theta plus tangent theta plus c. Okay, so that's not so bad. We've kind of done a lot of that before, but now this last part, we have never done anything like this. It's not hard, but you got to watch me carefully here. So our original problem was in x's. We substituted it in terms of theta so we could integrate. But we have to put our final answer back in terms of x. And the way we do that is with the triangle. So we need to write secant theta and tangent theta back in terms of x. So we go back to our triangle, and you say, okay, so secant theta, that's the reciprocal of cosine. Cosine was 2 over the radical, so secant's going to be the radical over 2. And then tangent theta is just opposite over adjacent, x over 2. So we replace those trig functions with their values in x. And so then they both have the same denominator, so let's just put it over that same denominator. Okay, and so that's our answer. All right, so see if you can do practice 1, please. All right, so Skylar, when you've got it.
Natural log of square root of 9 plus x squared plus x over 3 plus c.
Beautiful. Any questions on that? Okay.
Yes. Yes. Go over that.
Sure. Okay. So first of all, let's okay, so first of all, you draw the triangle. Okay? So, and then you make the substitution, x equals a tangent theta. So a for this one is going to be 3, because 3 squared is 9. So dx would be 3 secant squared theta d theta. So now you focus on the denominator here, okay? All right, so I'm focusing on the denominator. 9 plus x squared is 9 plus 3 tangent theta squared, or 9 tangent squared theta. Factor out a 9, and then 1 plus tangent squared is secant squared. So now when you put that under the radical, then see the square root of 9 is 3. Square root of secant squared is secant. So both of those are going to come out. And so now when the secant cancels with one of them on the top, the 3's cancel. So once again, you're just left with the integral of secant theta, which is the natural log of secant theta plus tangent theta. Finally, to put it back in terms of x, you look at your original triangle. And so the secant theta is hypotenuse over adjacent. Tangent of theta is x over 3. So you put those over the same, you just write them together, and that's the answer. All right, so questions on that, Jordan? You see where you messed up?
Yeah, I started all funny.
Okay,
Can you leave it there though?
sure. You want me to scroll back down?
Yes, please. All right, thank you.
You bet. Okay, so now you might recall from chapter 7 that the integral of dx over radical a squared plus x squared was also the inverse hyperbolic, well, the inverse sinh of x over a. So what we've just learned is from what we just did was doing it this way with the trigonometric functions. We got the natural log of radical a squared plus x squared over a plus x over a plus c. So what this means is that the inverse sinh of x over a is actually, you can write this as a natural log. So these are equivalent because we got the same thing when we did the integrals. Okay? All right, so then what we can do then is use that to rewrite the inverse sinh of x over 4 as a natural log. So see if you can do that. So using the formula you just wrote down, see if you can write the inverse sinh of x over 4 as a natural log. All right, so David, when you've got it.
I got the natural log of the square root of 60 plus x squared over 4 plus x over 4 plus c.
Excellent. Any questions? All right, good. All right, so now our second triangle, okay? So this is the substitution x equals a sine theta. I don't know why that's messed up. X equals a sine theta, okay? So as we have, when you have a squared minus x squared, then we plug in a sine theta and we'll get a squared minus a squared sine squared. We factor out the a squared and we have 1 minus sine squared, and so we get a squared cosine squared. And so then usually that's underneath a radical, and so then that will come out because both of them are perfect squares, and so we'll just get a cosine theta in our denominator. Okay, so let's go through an example of this one. All right, so when you have a squared minus x squared, okay, you put it down here and draw this triangle. So go ahead and draw this triangle next to the notes or something. Okay, and then the substitution that you're going to make for this one is x equals a sine theta. Okay. All right. So in this one, okay, so this is a little different in that it's got an x squared on top, which your practice problem doesn't have. So just kind of watch this one. So when we have radical 9 minus x squared, so we're going to so we draw our triangle, and then we're going to let x be 3 sine theta. All right, so now I'm going to focus on the denominator again. Okay? So 9 minus x squared is going to be 9 minus 3 sine theta squared. So that's 9 minus 9 sine squared. Factor out a 9. 1 minus sine squared. See, they all kind of do the same thing. And then you rewrite 1 minus sine squared is cosine squared. So now you put that underneath the radical, and it's going to come out. So you have x squared over 9 minus x squared. Oh, I forgot the dx. I forgot to mention the dx. So x is 3 sine theta. dx is 3 cosine theta d theta. Okay, so now when I plug in, see, I've actually got to plug in for x squared on the top. So that's going to be 9 sine squared theta. The dx was 3 cosine theta d theta. And then underneath the radical, I have 9 cosine squared, which that's going to come out to just be 3 cosine theta. All right, so now you're going to get the 3's cancel, the cosine thetas cancel, so you're just going to get 9 sine squared theta d theta. Okay, now we've actually integrated sine squared before. So we did it with the power reducing formula. So you might have that written down someplace, but if you use the power reducing formula, it just comes out to be 9/2 theta minus 9/2 times 1/2 sine 2 theta plus c. I've actually shown the steps up here if you forgot the integration of sine squared. Okay, and then finally we have to so here I wrote down the formula for the power reducing formula if you forgot the integration of sine squared. Also, I wrote down this other trig identity, sine 2 theta, because we've got sine 2 theta right here, and we don't want that. So that's 2 sine theta cosine theta. So the 2 and the 1/2 are going to cancel. So we just get 9/2 sine theta cosine theta plus c. Now, normally we wouldn't care if we had a 2 theta in our final answer. But the problem is that we have to put things back in terms of x. So we don't want a 2 theta. We want to be able to go back to our triangle, which just has theta in it. Okay? So that's what I've got to do now, that I've got everything in terms of theta. So now I need to put it back in terms of x. Okay, so now the sine and cosine are easy enough to read off the triangle. Okay, so sine would be opposite over hypotenuse, cosine is adjacent over hypotenuse. The thing that's a little tricky is theta. And so there's a lot of ways that we can rewrite theta, but the easiest is to say, well, that since the sine of theta is x over 3, then theta is the inverse sine of x over 3. Okay? So we rewrite theta as the inverse sine. So we have 9/2 times the inverse sine of x over 3 minus 9/2 of, okay, sine theta was x over 3. Cosine theta is the radical over 3 plus c. And so now the 9 cancels out with both 3's. And so we end up with that as our final answer. Whoops. Okay. So that was a little trickier. Had a couple of trig identities in there. Having to rewrite theta with the triangle. But it still pretty much goes through the same pattern. All right. So let's just see how you do on practice 3. Let me scroll up so you can see how to get started. All right, so Jordan, when you've got the answer, if you get stuck, let me know.
I got x.
I think it's a little bit more than that. Oh, ah. Okay. All right, so in this case, your A is going to be 2. Okay? And so you draw your triangle like that. And so your substitution is x equals 2 sine theta. So then your dx is 2 cosine theta d theta. All right, so now focusing on the denominator here. 4 minus x squared is going to be 4 minus 2 sine theta squared. 4 minus 4 sine squared theta. Factor out the 4. So you'll get 4 cosine squared theta. So when you put that underneath the radical, it's going to come out and be 2 cosine theta. Now the numerator, you just have the dx. You didn't have x squared like in the example. So that's going to make it a lot easier. So then, oh, I see what you were saying. Okay, so then all you have left is just d theta. So the integral of d theta, or 1 d theta, is just theta plus c. Okay? But that's not the answer. You can't leave it in terms of theta. So you have to go back to your triangle and say, how could we rewrite theta in terms of x? Well, since the sine of theta is opposite over adjacent, so the sine of theta is x over 2, the inverse sine of x over 2 is going to be theta. And so that will be our final answer. The inverse sine of x over 2 plus c. Okay, so you were all the way to the second to the last step. So you just got to do that last little thing and put it back in terms of x. Okay? All right, any questions on that? Okay, the last one. So the last one, the third triangle, is when we substitute x equals a secant theta. So this is when you have x squared minus a squared. Then you substitute in a secant theta, so you'll get a squared times secant squared. When you factor out the a squared, you'll have secant squared minus 1, which becomes a squared tangent squared. And so usually when that's underneath the radical, it'll come out to just be a tangent theta. All right. So you're going to want to draw the triangle like this. Okay, so you might want to draw that next to the note someplace. Oops. Okay. All right, so now let's go to the practice problem. Okay, now one other little wrinkle that we have here is you depending on how you want to do it, you can either factor out the 4 or think of this as 2 squared minus 5 squared. And think of this as like your x and then 5 as your a squared. Okay? But you're going to have to deal with that 4 somehow. Okay? So I think this is a little bit easier to do it as to draw your triangle like this, where so you'll have 2x is your hypotenuse, 5 is one leg, and radical 4x squared minus 25. So then the secant of theta would be 2x divided by 5. All right, so see if you can finish it off from there. All right, so Aiden, when you've got it or if you get stuck, let me know.
Yeah, I'm stuck.
Okay. All right, so did you get as far as this? So, okay, well, if secant theta, so secant theta is 2x over 5. Okay? So then when we solve for x, it's actually going to be 5/2 secant theta. So that's where it's a little bit different, because before with the a was, we just had to deal with 5. But on this one, it's 5/2. So the dx would be 5/2 secant theta, tangent theta, d theta. So now, focusing on the radical. So radical 4x squared minus 25 is 4 times 5/2 secant squared minus 25. So then when you square the 5/2 secant squared, you get 25/4 secant squared minus 25. So the 4's are going to cancel. Factor out of 25. And then secant squared minus 1 is equal to tangent squared. And that's going to come out of the radical as just 5 tangent. So then when we put the numerators, 5/2 secant theta, tangent theta, the denominator just becomes 5 tangent theta. 5's cancel, the tangents cancel. So we're 1/2 the integral of secant theta, which is the natural log of secant theta plus tangent theta. Then we go back up to our triangle and write secant theta and tangent theta in terms of x. So we can put them together if we want.